And welcome everyone to our weekly call. As you'll see from the screen, I'm delighted to say we're joined this week by Audrey Randall from UCSD, who has kindly agreed to reprise a presentation or elements of a presentation that I first saw her deliver at IETF 110 during the IRTF Open session. So this is officially an award-winning presentation for anyone that saw it there. So we're going to, in a moment, I'll hand over to Audrey and she can talk about, as you can see from the screen, Tufflehunter and cache snooping, which I know will be of interest to quite a number of you on the call. We'll have, as always, plenty of time for questions afterwards. And for those of you that you can use the Zoom facility to raise your virtual hand as appropriate. Equally, those of you that can't, feel free to pop any questions in the chat. And then when we get to the end of the presentation, I'll read out any on there and we'll pick them up as we go on. Once we've done that, then if time permits, we'll pick up on any other topics at the back end of the call. But without further ado, let me hand over to Audrey. Thanks again, Audrey, for making time to join us on the call today. And the floor is yours.
Thank you for the introduction. So yes, as Andrew says, my name is Audrey. I'm a third-year PhD student. And this paper was actually originally published at IMC and is entitled Tufflehunter, Cache Snooping Rare Domains at Large Public DNS Resolvers. So the whole point of our group at UCSD is to measure harmful internet behavior. That's just what we do. And in the past, we've done a lot of things like spam emails or botnets or certain types of malware that I would classify as more common. And the thing about common internet abuse is that it's well studied because it's kind of easy to find. But there's a bunch of rare internet abuse, in particular stalkerware, which is the problem I'm most interested in solving, which is much more rare, as in it's very hard to find any signal when you're looking at internet traffic from any of these types of harm, and that makes it sparsely studied. So that's the stuff that we're really interested in measuring. And to measure it, you have to come up with some more creative techniques. So we started this project with the observation that, all of these types of harm, hack for hire services, typo squatting that is used in phishing attacks, and stalkerware itself, all of them have to make DNS requests to some server that they require to function. So we thought, there's this technique called cache snooping. It's been around since at least 2004. Why don't we try and use that to measure its prevalence? Of course, there's a couple of disadvantages of cache snooping. The first is privacy, which I'll get into in a second. And the second is that even if you can get around the privacy disadvantages, cache snooping only provides a lower bounded estimate of the number of users that are accessing a domain. Now, it turns out in our case, because we're looking for such rare things, cache snooping is actually not such a problem. The lower bounded estimate is not such a problem, because if you're looking for the kind of things where you're not expecting too many people to visit the same cache because it's so rare, then cache snooping can provide a very accurate estimate of how much is out there. So in terms of the privacy problem, we observed that most people have used cache snooping in the past by just scanning the entire internet for any device that'll answer a DNS request. And the problem with that is a lot of those devices are actually people's misconfigured home routers. So of course that's a privacy threat because you've only got a few people behind each of those routers. And if you find a domain in those routers' cache, it's easy to tell who exactly put it there. But we thought there's these public resolvers that are getting more popular. And they have so many users. If you could work out how to use cache snooping on a public resolver, you could use it as a privacy preserving measurement technique. Because they have so many users, we think it's impossible, well, shouldn't say impossible, but as close to impossible as makes no difference to figure out who put a domain into a resolver's cache. So we decided to try that, but of course, public resolvers are also going to be more challenging because they've got so much more complicated caching strategies. And we also found some unexpected behavior while we were going through this that complicated our work as well. So from an outsider's perspective, the reason that public resolvers are so hard to snoop is because they have so many caches. When a user is going to make a query, they first have to be routed to the nearest POP through Anycast, and that gives you a choice of data centers to get to just right off the bat. And then all that we knew about how the POPs were set up when we started this project is that they've got a whole bunch of front-end caches and a whole bunch of back-end resolvers that also have caches of their own. So each of those caches represents a place for us to measure a different user, a different cache. But the problem is we need to be able to tell which caches our queries were hitting. So that was the first challenge we had to overcome. So for the remainder of this talk, I'm first going to briefly cover how we reverse engineered public resolver caching strategies. And then I'm going to talk about how our tool works and some of the challenges we had in making that work. And finally, I'll cover the case study, so the actual measurements that we made. And I'll start off with public resolver caching strategies. So how we actually modeled these cache architectures from the outside is from a single vantage point. We did an experiment where we repeatedly queried each resolver to try and fill as many caches as we could. And then we tried to look at how those queries were cached by looking at their TTLs and their timestamps. So we graphed their time on the x-axis against TTL on the y-axis, and we came up with this model of a TTL line. So a TTL in a cache ought to decrease by 1 second per second. So if you draw a line with a slope of -1 through any one measurement, any measurements that came from that same cache should fall onto that same line. That's the green line in the picture here. Then, if you want to count how many caches have been filled, all you should have to do is count the lines. Of course, it turned out there was some complexity there, which I'm not going to get into too much detail about here. Feel free to read our paper for more information. But when we did this, we found out that every public resolver we looked at had a different number of caches visible to outside users. And that made some of them better for this technique and some of them a little bit less useful. So for OpenDNS and Quad 9, we found out that their front-end caches operate independently, as far as we could tell. So there were a whole bunch of front-end caches at each POP that we could measure, and we could measure up to about 80 users at most of the POPs. For Cloudflare, on the other hand, we found that their front-end caches were shared and distributed. So they all fronted onto a single back-end cache, and from an outsider's perspective, it only looks like there's one cache per POP. So we could only measure one user per Cloudflare POP, which made Cloudflare a little bit less useful for measuring stalkerware usage. And then finally, there was Google Public DNS, which was really interesting because it let us measure a lot more caches than we actually expected to be there. And that was unusual, so we dug into it a little bit further. And we found out that Google was actually doing something where they'd have if a request came in and it missed in a front-end cache, and it hit the back-end cache, then the front-end cache would reset the TTL when it got filled. So that allowed us to differentiate each of these front-end caches from each other, and it actually let us measure about 10 times as many users on Google as we could anywhere else. So unfortunately for us, this behavior actually turned out to be a bug, and Google, someone from Google contacted us after the IETF meeting when I last gave this talk and said, oh, it was a bug. It was fixed in January of this year. And we went and checked, and that behavior is indeed no longer visible. So unfortunate for us, but of course oh, sorry, question? Thought I heard someone say something. Oh, Andrew, you're muted.
I think that was just some line noise.
Okay, cool.
So carry on.
All right, so yes, so sorry, yes, Google behavior turned out to be a bug and it is no longer visible. So after we had figured out how the public resolvers worked and how their caching strategies operated, we were able to measure how many caches our queries had hit. So we set up this tool called Tufflehunter. And Tufflehunter, being our distributed measurement tool, we deployed it on Kata's Archipelago project. That project is very useful for anybody interested in doing internet measurement. They've got about 45 different monitors deployed across the United States. We were just looking at the United States for this work. And each of those monitors is just a Linux computer that you can basically do whatever you want on. So it's a much more flexible tool than Ripe Atlas or something like that. So we set up Tufflehunter just to send repeated DNS queries across the United States. And all it does is send those continuously. And when the responses come back in, it tries to estimate how many caches have been filled and how many users it's seen based on our models of the public resolvers. And we've got 3 months of data for this particular experiment between March and May of last year. So the first challenge that we had to overcome when figuring out how to count these caches was figuring out which pop we had, which pop each query had hit. Turns out public resolvers provide location queries for this purpose, for debugging purposes. On Quad9 and Cloudflare, those are, of course, the chaos id.server queries. And then Google and OpenDNS have text records that are available for folks to use. So that was really useful. That was a lifesaver when we found out those exist. So we would run those once per minute. And we found out that location churn for each monitor we were using was actually usually pretty low. They would go through these long stable periods when they didn't switch which pop they were contacting. And sometimes they would hit these short unstable periods. So for up to half an hour at a time, we would see them flutter between different pops. The next problem that we had was, of course, that our model of cache architectures might not be accurate. So we had to see how good we were at estimating how many filled caches each resolver had. And this turned out not to be entirely straightforward. So we ran this experiment where we used write atlas this time to imitate people's phones and real devices. And from the write atlas nodes, we placed a domain that we controlled into resolver caches. By domain we control, I mean that we controlled the authoritative name server. Then we tried to observe that domain with Tufflehunter, and we took every request that came into our authoritative name server as representing a true filled cache. And then we calculated our error in the number of filled caches as you see in this figure. So for OpenDNS, we did the best out of all the 4 resolvers that we studied. And you can see that we kept our error reasonably low there. For Cloudflare, there was one particular pop where we think there was some routing going on that we didn't account for. Maybe there was a node that was going through some of this fluttering behavior. So our error was very high on one particular pop, but on the rest of them, it seemed pretty low. For Google, that bug that I mentioned earlier turned out to make it difficult to accurately estimate how many filled caches we were seeing. But we still managed to keep our error largely in the negative direction, which is what we wanted. And then Quad9 had some really interesting behavior. Quad9 has about the same architecture as OpenDNS from an outsider's perspective. So we thought that our accuracy would be about the same on Quad9 as OpenDNS. Turns out not to be the case, because Quad9, to the best of my knowledge, correct me if I'm wrong, is running 2 types of software at their backend resolvers. And if one of those types of software gets the query, it actually doesn't respond to recursion desired equals 0 requests, which is how we were performing the cache snooping. So 50% of the caches at Quad9 become invisible to us because that software does not answer our queries. So our error is about 50% undercounting. The important thing to note about all of the error here is that we were able to tune it so that it's always undercounting rather than overcounting. And that's consistent with our goal of creating these lower bounded estimates of prevalence. And then finally, cache snooping in general has this limitation that you are bounded on the users you can observe by the number of caches that you can see at any one time. So of course, we can't observe any more users than there are visible caches at each of these pops. So we measured how many caches we saw at any one time so that we would get a sense for how much that would be. On Google, you can see because of this bug that turned out to be so useful, we could see about 10 times as many users as we could on OpenDNS or Quad9. And OpenDNS and Quad9 both have particular pops, which we think are busy, so they have more caches than the other pops. And then Cloudflare is not shown here because they've only got 1 cache per pop. So having figured all of that out, I will go now into the case studies, because once we'd figured that out, we were ready to actually use this tool. We ran 3 of these. So stalkerware, contract cheating, which is a new type of cheating that the kids are doing these days, and then typo squatting, mostly because we had the data and we wanted to see what was going on with it. All of these things we chose because they were previously hard to measure, and in most cases, we didn't have very much data about how prevalent they are. I'll start off with stalkerware. In case you haven't heard this term before, it's kind of this emerging spyware threat. It's software that's usually, well, in the cases that we are most interested in, it is installed by an abuser on a victim's phone, usually without their knowledge. Stalkerware's capabilities includes recording location, it's got keyloggers, it can record all sorts of different chat apps. It can even in some cases turn on the camera and the microphone to record ambient sound and video. So it's pretty dangerous stuff, pretty invasive. And some of it can hide its presence on the phone. So you go and look for an app icon and you're not going to find it. You go and look through the list of installed apps. And unless you know that something calling itself data backup or Wi-Fi is actually a stalkerware app, it's really hard to tell this stuff is installed. So we downloaded and profiled 24 of these. Stalkerware kind of comes in two categories. The first being these dual use apps. So dual use apps are usually marketed for a legitimate and legal purpose like parental control or employee surveillance, but they can be abused to act as stalkerware in an intimate partner violence situation. And then we also downloaded 16 overt apps, and an overt app is one that advertises itself as being undetectable, although they have varying success with this because a lot of them seem to be poorly designed. And they're often marketed for intimate partner violence specifically. So once we had these apps, we recorded all of their network traffic to figure out what DNS requests they were making. Then we could feed those domains into Tufflehunter and look for them. Now, a little bit more detail about why stalkerware is so hard to study by other means, because stalkerware really is the perfect use case for Tufflehunter. The thing about stalkerware is that most of the prior work has been in clinical settings. So that means researchers have been speaking one-on-one with individuals. And unfortunately, anywhere where you're doing that, you're going to have a low sample size problem because it doesn't scale very well. As a consequence, at the time that we started this project, there actually weren't very many overt apps that had ever been seen in the wild, but we were talking a sample size of perhaps 50 people. So the next problem was that targets often reset their devices by the time they are worried enough to go into a domestic violence shelter. So it's difficult to tell if stalkerware was installed there before. And finally, these clinics usually lack the technical expertise to figure out if stalkerware was on a phone. And even if they can figure that out, oftentimes they don't make very good records of it. So it's been very difficult to tell how much of this stuff is out there. And then the last problem was that with so many of these dual use apps, rather than the overt apps being found, the attitude in this research community was that the overt apps were not the problem. So nobody was studying them. So we said, all right, perhaps they are not the most common problem, but how much of a problem are they? And in order to figure that out, up until this point, we've been talking about counting caches. We had to switch to counting devices instead. And the last reason that stalkerware is such a perfect use case for Tufflehunter is that it often makes its DNS requests automatically, and that means regular intervals. So we can use those regular intervals because if you divide the number of filled caches you see by the app request rate, you can actually get a pretty good sense for how many devices there are with stalkerware installed. And when we did that, we found that there are at least 5,700 people, just as a lower bound, that are being targeted by specifically overt stalkerware in the US today, which is more than anybody had found so far by a long shot. We found the most popular of these were an app called Mobile Tracker Free and Spy to Mobile. And we think that makes sense because Spy to Mobile was the only overt app we saw that was available on the Google App Store, because most of these things are not allowed on the App Store. So that means it was easier to find. And Mobile Tracker Free was the only free stalkerware that we found. The rest of these things cost at least $20 a month. So we thought it made sense those were the two most popular. We also looked at the dashboard visits, although in this case, we could only count the number of filled caches rather than the number of users. When I say a stalkerware dashboard, I mean the website that the stalker visits in order to view this uploaded information. And again, we saw that Mobile Tracker Free was the most popular dashboard, but other dashboards seem to be popular as well. The second case study that we looked at was contract cheating, which are these services where they're not plagiarism. Thus, a student will just contact these services and say, all right, here's my homework assignment or my project description or whatever, and they will pay the service to do their homework for them. And it's quite difficult to detect automatically because it's actually original content, so plagiarism checkers won't work. So we found a whole bunch of websites for these contract cheating services, and we looked for them on Tufflehunter. And we noticed something interesting, which is over the last half of May, which is when we were running these experiments, we saw that some of these services were decreasing over time. So we were speculating that maybe this was schools letting out for summer break and the cheating market decreasing over time as students had less use for it as summer started. But we'd have to dig into that in more detail to prove it. And then finally, we looked at typo squatting, but we particularly looked at typo squatting for these really old domains. Because the conventional wisdom is that really old typo squatting domains shouldn't be getting any traffic. They have a lifetime, they expire very quickly. We actually found that they were getting multiple requests per day, dozens of requests per day, even though these things were about 5 years old. So that was interesting. It suggests there's really a long tail on these typo squatting domains. So the takeaway that we got out of this work was we don't think cache snooping is actually a privacy threat on public resolvers. We think it's a valuable measurement tool that lets us measure this type of harmful behavior that we can't really measure any other way. Such as, the things that we looked at, and as well, there are some other phenomena that it would be nice to look at in the future that we haven't had a chance to study yet, such as these hack for hire services or phishing. So to conclude, we figured out how to use public DNS resolvers to enable privacy-preserving cache snooping. We think that's a valuable measurement technique that shouldn't yet be disabled, and we used it to find non-trivial lower bounds of the prevalence of these hard-to-study internet phenomena. I have a few questions for operators, since I've been told that that's what this call is all about. So first of all, I'd like to hear from you about what do you think about cache snooping on public resolvers, because I realize there's two courts of opinion here. There's the court that says absolutely get rid of it, and there's the court that says, well, it's not so bad after all. And then I have a slightly unrelated question, but as long as I have you all here, if anybody is an expert on Comcast routers, we have some questions about that, and I'd love to contact someone and maybe take that chat offline. Thank you for listening. Questions?
Perfect. Thank you, Audrey. Well, let's see if anyone's bold enough to answer either of those two questions then. So any thoughts on the use? I see John. Excellent. For Audrey's benefit, if you don't know John Todd is the exec director for Quad9. So I'm genuinely fascinated to get John's point of view on this.
Actually, Audrey and I have spoken on this topic at length in the past. But actually, I wanted to ask a question rather than address the RD equals 0, because I'm probably not going to address that right now on this call. But so my question is: are you aware of the research that Jeff Huston did on DNS zombies? And essentially queries that come into recursive or authoritative resolvers that seem to have no discernible origin or no discernible event that causes them to happen.
Huh. I'm not aware of that. What was the name you said?
Jeff Huston. I'll send you a link. Just look up Google's DNS zombies, and I think that will get you his research. And let me make sure that that's the case here. DNS zombies, and yes, that will get you a couple of discussions that he had about mystery DNS requests.
Yeah.
So yeah, that's really all I wanted to respond to. The RD equals 0. That's a longer question. I can't answer that on this call, I'm afraid.
Thank you.
Thanks, John. Out of interest, John, because I know Quad9 does block malicious content. Do you treat any of those categories as malicious content?
Interesting question. It's like you queued that one up. As a matter of fact, yes. We have ingested the list actually as a reference from this. Ultimately, from this initial talk, we've talked to some folks in the project and now have a list of stalkerware domains, and so no longer do you have to actually guess which domains are being populated. We actually have a count of them. The numbers are surprisingly high. We thought we would ingest this list, which is only a few dozen, I think, domains, if I'm not mistaken. And it turns out to be, or at least at one point, it was hundreds of thousands of blocks per day that we were seeing on the stalkerware. And these were the covert, I think, only, I believe, that are being blocked. So these are essentially malicious, or that they have no discernible use in a legitimate fashion. So surprisingly high. I would ask anybody who's doing any kind of block list to reach out to Audrey or other people on the project and see if you can get those into your list. They serve a very good purpose to protect domestic violence victims or people who are in situations where there's bad things that may happen as a result of that. So, but yes, it's quite an active set of DNS records in the stalkerware community.
Thank you. I can see Peter Lowe from DNS Filter has his hand raised. So do you want to jump on, Peter?
Hi, Audrey. Thank you very much for your presentation. It was fascinating. DNS Filter, we do a similar thing to Quad9, but on a commercial basis. And I would love to see the source list of domains that you have. I wanted to ask, are you keeping it up to date? And are you investigating like new apps, new stalkerware apps, or that kind of thing? Is this an ongoing project?
So this is an ongoing project, trying to make an automated way to detect which apps are popular and figure out what DNS requests they're making is actually one of the big projects in the stalkerware research community right now. There's a whole group of us with a Slack workspace of our own that are always trying to figure out how to make this easier. At the moment, it's mostly on a volunteer basis. So there are a couple of people, at the moment, not me, but people who I work with who are trying to keep this list up to date. And I'd be happy to put you in contact with that project.
Yes, please do. I will
Awesome.
see if I can find a way to contact you. I'd love to join your Slack group, but I'll talk to you offline about that, I guess.
Sounds good.
Thanks.
Thanks, Peter. And Ralph Weber from Akamai has also raised his hand. So do you want to jump in, Ralph?
Hello, and thanks a lot for the talk. On the topic on RD=0 support, have you considered looking at the kind of response times that you get from the host? Because what I found in this, I mean, I look at DNS data a lot, and I can pretty much, with near 100% accuracy, say if a record was cached or not. I mean, it requires some amount of distribution. You need to know kind of that domain or that part of the network has these usual response time, but just using response time should be sufficient to actually identify if something wasn't the cache or not, or?
Interesting. So we considered it as a possibility when we first started this project, but our impression from our first measurements of the public resolvers was there was going to be so much complexity to work out that we didn't want to add another layer of noise. But now that we have a good understanding of how these resolvers work, you're right, that is a good option that we should investigate.
Thanks.
Okay, thanks, Ralph. Does anyone else have any questions? Either through raising your hand on Zoom or indeed putting something in the chat. And whilst you're thinking, if I try and address your question, Audrey, on Concast routers, one of our regular participants from Concast, I note, isn't on the call today. So I'll happily reach out to him after the call.
That would be wonderful. Thank you.
With a request. Of course, if anyone who is on the call happens to be an expert in Concast routers, by all means jump in and say so. But otherwise, Comcast would seem like a good place to go for that expertise.
Sorry, Andrew, I couldn't find the mute button fast enough. I just wanted to jump in if that's okay. So in Canada, we operate a non-public name cache farm for our customers, right? So we don't have a public caching environment, but I am very keen and interested on some of your comments around botnet and all of this other stuff that you're working through, which is, I'm not sure if you're familiar with the regulator in Canada who's asked all Canadian telecom providers to work out a framework for doing botnet detection and mitigation. So that, along with the work that you're doing, I think there's a lot of things that I'd like to get more in touch with you. So it's something I just wanted I don't know if there's a way to get in touch with you offline here about this, but I got lots of questions.
Yeah, absolutely. I should have put my email on this slide. My apologies. Perhaps I can send that to Andrew after the meeting, and anyone who wants to email me can use that.
Yeah, well, I'll put that.
Sorry, yes, you have my email. That's how you found me in the first place.
Good point. Yes. Yeah, I'll share that afterwards, Audrey. So anyone else that wants to follow up. And Ron, I think you're Shaw.
Correct. Yes.
Yeah.
Shaw Communications in Canada. Yep.
Oh, interesting. Yes, we actually want to talk to you as well. We've got some measurements running in your network.
I was actually just talking with my DNS team, and they're very keen on this. Absolutely.
Awesome.
Fantastic. Good. All right. Thank you, Ron. Jim, I can see has raised his hand. So, Jim, do you want to jump on?
Yeah. Thanks. Interesting talk, Audrey, as always. Just a quick question on this issue of support for RD=0. I have a horrible feeling that that's not the question for the operators themselves, because I think it's a feature of one of the recursive resolver implementations. So if you just answer these questions which have got that, which don't have that bit set.
Oh, everyone's frozen.
Have we lost Jim?
I believe I'm still here.
Oh.
Okay. Sorry, perhaps I missed the last bit of what you said. Something about you just answer all the queries with that bit set.
I think that one of the resolver implementations, I think it might be actually Unbound. If you just the queries that have got RD=0, you just don't do it.
Yeah, Unbound returns a refused status code when you try and ask with RD=0.
Yeah, so I don't think it's a question of policy for the operators. It's a question for the implementers. And
gotcha.
In that case, then the operator has to make a decision if they want to swap out Unbound for something else.
Gotcha. It isn't a configurable thing in most resolvers?
Well, it's not configurable in resolver implementations. I think the Unbound guys have chosen hardwired this into the code that they're not going to answer these types of queries. They're just going to refuse them point blank. So the question then for an operator is, if you wanted to have a mix of resolver implementations, if you're going to rule out Unbound because of this behavior, that narrows your choices and perhaps other ways which are undesirable. And after all, Unbound's a really good recursive resolver. So why would you not use it?
Right. Cool. Good to know.
Okay. Thanks, Jim. That was interesting. Okay. Anyone else got any questions for Audrey? Either by raising your hand or putting them in the chat. Unusually today so far, we've not had any questions in the chat, which is usually the other way around, if anything. I'll just give you one last chance for any of those. No. Okay, well, look, thank you, Audrey. That was as interesting as the first time you gave the presentation, well, the first time I saw it, at least, at IETF 110. I'll as just discussed, I'll put your email details out after the call, and then sounds like various people will be following up with you enthusiastically with some follow-on questions and discussions. So it sounds like you're going to be busy in your third year.
Hope so. Hope so.
As well as going to various conferences, because I think you're at, is it DNSOR, I think?
Yes, yeah, I'm actually giving the same talk on Wednesday evening, I think, so I hope too many people aren't going to hear it again.
Yeah, slightly less sociable hour for those of us in Europe, to be fair. But,
true.
But yeah, so brilliant. So thank you for your time today. It's much appreciated, and hope you get some useful follow-up from the call. All right, so let's move on then. That pretty much takes us on to any other business this week. I firstly wanted to let you know that since our last call, I've managed to speak to the team at ICANN about their kindness project. So that answers the first question. Those of us who aren't sure how to pronounce it, that's CINDNS, is intended to be pronounced kindness. And we're going to be covering that particular project on this call in a couple of weeks' time. In fact, if I just look at my diary, I'll check the exact date. Monday the 24th. So in 3 weeks' time, we'll be covering the kindness project with Adiel from ICANN. So I think that will be of interest to people. So thank you. I think it was Ulrich who brought that up 2-3 weeks back. So it definitely does sound like that will be of interest to various of us on the call. So that was the main thing I wanted to mention this week. So does anyone else, and I see whilst I've been talking, Audrey's kindly put her email in the chat, so anyone that's looking at the chat can pick that up whilst we're talking. So does anyone else have anything they want to raise this week? Anything that's on your mind, any sort of hot topics or other questions that you want to bring up? As unusually, we do have a few more minutes than we often end up with on the call. So any comments or questions from anyone? I'll take silence as possibly not this week. In which case, let's call a pause there and give everyone sort of 10 minutes or so back in your diary at the start of the week. So thanks everyone for joining this week. Thanks in particular Audrey for taking time out to walk us through Tufflehunter and associated activities. Have a great week everyone, and we'll speak again at the same time next week. Have a great week all.